All right, today we're going to work on lesson 4.2, which is on rate of change and slope. You're going to see how similar these two really are. We're going to look at them in a couple different comparisons. But the bottom line today is we want to be able to interpret the rate of change and slopes, and we want to be able to apply these to graphs and making graphs. Okay, so first of all, we deal with slopes of lines. The idea is that the slope of a line is the rate of change of the y coordinates, which is the rise. Remember, the y is the vertical axis to the corresponding change in the x-axis, which is called the run for the points that are on that line. So M is the letter we usually use for it. So this little cursive M stands for slope and is simply defined as rise over run. And then remember, we said it's the change in y's. That's the difference in the subtracting the y coordinates over the change in x, which are the x coordinates. Okay. So you got to make sure you do difference in y's over difference in x's. And that's how we find a slope if we're given a couple of points. Okay. Now, in general, there's four different types of slopes. We have a positive slope, which is a line that rises from left to right. So as you look at it, as you move across from left to right, the line should be going up. We have negative slopes, which as you move from left to right are going down. We have a zero slope, and that represents a horizontal line. So if your line is horizontal, it has a slope of zero. If you go to calculate the slope using this concept up here, the difference in y's over difference in x's, what should happen is your y should give you a zero. You should have zero over some number. It doesn't matter what the number is on the bottom. Zero over 2, zero over 10, zero over negative 80. Doesn't matter. Zero over a number is zero. That means you have no slope. It's a flat line. It's a horizontal line. Okay. An undefined slope, that comes from a vertical line. Okay. And then, same idea. If you go to calculate points that are on a vertical line and find their slope, you're going to wind up with a number over zero. Zero's in your denominator. And we cannot divide by zero. Remember, this is really division here. We cannot divide by zero. So this would be considered undefined. Okay. Anytime you get a zero in the denominator, it is undefined. And that's a vertical line. Okay. So the first type of questions here are real simple. Just in general, what kind of lines are these? Positives, negatives, zeros, or undefined? Well, the first one here is this vertical line. Okay. It would be x equals some number. Let's say it's x equals 1. That's a vertical line. Anytime you have a vertical line, excuse me, you have an undefined slope. The second one, as you move left to right, this line is going down. As you move left to right, it's going down. That's a negative slope. And number three, as you move left to right, your line's going upwards. So I know that is a positive slope. And in number four, that's a horizontal line. It has no slope. It has a zero slope, right? It doesn't slope up. It doesn't slope down. It is straight across. It's a zero slope. Some more of these just to take another look here. Again, we start out with one that is a horizontal line. It has a zero slope. This line, it's rising from left to right. So that means its slope would be a positive number. This one is falling from left to right. So its slope would be a negative number. And then the last one here, that's a vertical line, and a vertical line has an undefined slope. We can't define it. It's straight up and down. Okay. So that's classifying slopes just by looking at a picture. And we're not finding the exact slope. We're just telling them what kind of slope it would be. Okay. Now down here, all right, they give us a graph and they highlight 2 points on the line of this graph or this line graph. And uh, they're asking us to find the slope that's between these two lines. Okay. So to find the slope between these two lines, there's really two ways we can do it. All right. One way we could do it is really kind of the simple way is remember slope is rise over run, rise over run. So what is the rise and run from this point to this point? Well, we would go up three, one, two, three. You're always moving vertical and horizontal. So we go up three and to the right five. Now up in the y direction is positive. To the right in the x direction is positive. So this would be positive 3/5. We could also do it using the definition, which is, y2 minus y1 over x2 minus x1. We can get the answer the same way doing that. So let's go ahead and do that. This point is located at -1, -2. This point is at 4, 1. So I'm going to take these 2 points and use this formula. All right, I'm going to go difference in y, so 1 minus negative 2 over difference of x is 4 minus negative 1. 1 minus negative 2 is really 1 plus 2, so that's 3. Minus negative 1 is really plus positive 1, so we wind up with 3/5 again. Same answer. I just did it using the 2 points rule rather than just using rise and run. Okay, over here, find the slope using rise and run. Or excuse me, slope is rise over run. So now this one, I'm going to move from this point to this point. If I do that, I'm going to go up 6 units, which is positive. Remember, moving upward is positive. When I move to the left now, I'm moving negative. When I move to the left, I'm going in a negative direction. So that's a negative 5 units. So the slope here is going to be 6 over negative 5, or just negative 6/5. Okay. So rise over run. All right. Now I could do it using this way too. So let's reset here. This point up here is at the point negative 3, 2. This point is located at 2, negative 4. Apply the formula, difference in the y's. So I went 2 minus negative 4. And then I went negative 3 minus 2. Minus a negative is plus. So the top's going to be 6. Plus a negative on the bottom is going to be negative 5. Obviously, it's going to be the same slope. Doesn't matter which way you do it, you're going to get the same slope. Okay? So the next idea, though, is how do we find the slope of a line if we're given 2 points? Now, we're not given a graph to be able to look at the rise and the run. So what we're going to have to do now is use the formula. Okay? So let's take a closer look, though, at the formula. I kind of use it on the last one. I want to make sure everybody understands how this works. So what we're going to do here is basically assign one of the order pairs to be the first order pair and the other one to be the second. And it doesn't matter which one's which. But if this is the first order pair, then I would call this one x sub 1 and this number y sub 1. This is x from the first order pair, y from the first order pair. This then I call x sub 2, and this one will be y sub 2. Okay, so then based on my formula, the way I have it arranged, I'm going to go negative 9 minus negative 3, the difference in the y's, and then 8 minus negative 4, difference in the x's, right? That's going to become negative 9 plus 3 on top and 8 plus 4 on the bottom. Negative 6 over 12 reduces to negative 1/2. So there's our slope. Now, I just want to show you on this one. So what happens if I do switch the order pairs? Let's say I decide to call this order pair the second, x2, y2, and this one we'll call the first order pair x1, y1. Well, if I follow my rules, you're going to get the same answer. It doesn't matter which one you call which, you just have to do it consistently. So in this problem, I would go negative 3 minus negative 9 and negative 4 minus 8. That would become negative 3 plus 9, negative 4 plus negative 8. Okay. That's going to give me positive 6 over negative 12. And just like up above, it's going to simplify to negative 1/2. Remember, this is kind of like division, right? So negative 6 divided by a positive would be a negative. Down here, a positive divided by a negative would be a negative. So you get the same answer. I just want to show you that whatever order pair you decide to use first, you just got to use it first in both cases. Okay. Obviously, you don't have to do this. You don't have to do it both ways. Okay, this one says find the slope of this line. And again, I'm just going to set up my slope formula. I like to write that out first, and then I'm going to assign this x1, y1, x2, y2. Okay, so I'm going to go 6 minus 2 on top, and then 9 minus negative 7 on the bottom. So 6 minus 2 is 4, plus a positive 7. So I get 4 over 16, or 1/4. Real simple. Not going to do it both ways. I just want to show you that it worked that way. But this one is 1/4. Okay. Now, what happens if you have horizontal and vertical lines? All right. Well, the question looks exactly the same. Okay. But let's go through the process here. To find the slope of a line that goes through these 2 points, we're going to go y2 minus y1 over x2 minus x1. Right. So I'm going to go negative 6 minus negative 6 on top, difference in my y's, and then 6 minus negative 9 on the bottom. Okay. Now that's going to become negative 6 plus 6 over 6 plus 9 on the bottom. And I'm going to get 0 over 15. All right. 0 in the numerator means what? It means the slope is 0. If the slope is 0, that means we got a horizontal line. Okay, it's a horizontal line. Now we actually know what the equation is because if you look up here, what do you notice about the ordered pairs? They have the same y value. Okay, they have the same y. That's why the numerator canceled out. Remember, the y's are up top here. Because they have the same y value, that's telling us where the line's going. It's a horizontal line where y equals -6. Y is -6 in both cases. Okay, another one. Find the slope of a line that goes through these 2 points. So again, I'm just going to go to my slope equation. I'm going to plug it in. -8 minus 1, difference in the y's. 7 minus 7, difference in the x's. I'm going to get -8 plus -1 over 0, -9 over 0. Now, when we get 0 in the denominator, what does that mean? Well, it means the slope is undefined. What kind of line gives us undefined slope? Vertical lines. All right. And if you look up here, notice their x's are both sevens. That's why the denominator canceled out because they both have a 7 in the x position. That means the equation is x equals 7. Okay, one more of these. Find the slope of the line that goes through these points. Same directions, same process, difference in the y's over difference in the x's. So we're going to go -3 minus 5, -2 minus -2. It's going to become -3 plus -5. And this becomes plus a positive, so -2 plus 2. So we're going to wind up with -8 over 0. Okay. Doesn't matter what the top number is. If the bottom number is 0, this is undefined. And if it's undefined, it's a vertical line. And if I go back up here, I notice both of the x coordinates are -2. That happens to be the equation right there. Okay. Then the last thing we're going to do is look at rate of change and slope, how close these two are to each other. Okay. And really the only difference is rate of change, we label, the rise and the run, so to speak, and the slope, we just speak of it as a number. So here's what we got. Linda makes house calls. For each call, or for each, she is paid a base amount and then makes an additional money for each hour she works. The graph below shows her pay in dollars versus the number of hours worked. Okay, so if we go down here, we can see the x-axis is goes by ones and it's the number of hours worked. The y-axis is going up by tens and it's the money she's paid. Now, looking at this, you can see we start right here at 40, and then from there we're going up. So what that tells us is she's making $40 just to make the house call. So she gets 40 just for going, and then she gets money per hour from there. Now, how much does she pay increase does she get per hour? Well, that's just kind of a matter of finding slope, right? If I go up 10 and over 1, I go to the next hour. So a rise of 10, a run of 1. And this is consistent. A rise of 10, a run of 1 to the next point. A rise of 10 from there, a run of 1 gets me to the next point. Okay, so what does that mean? That means rise over run, she's making $10 per 1 hour or $10 an hour. See, this is a rate of change, $10 per hour, because we're labeling it. Down here, what's the slope of the line? Well, I'm really using the same information. It's a rise of 10 and a run of 1. So the slope is 10 over 1 or just 10. Up here, because it's a rate of change, I'm doing labels. It's a dollar amount per hour. Down here, I'm just doing a number. If the rise is 10, the run is 1. Okay, so that's how close those two are. Another one, a bucket's being filled with water. The graph below shows the height of the water in millimeters versus the time the water's been running in seconds. All right, so we come down here and look. We can see our x-axis is time in seconds, and we're going every second. We're marking it. The y-axis is the height of the water in millimeters. We're going by fives. Okay. Question is, how much does the height of the water increase for each second the water is running? All right, well, let's look at this rate of change here. So we go up 5 millimeters for every 1 second we go over, up 5 millimeters over a second, up 5 millimeters over a second. All right, so what is our rate of change here? 5 millimeters per 1 second, or we could just say 5 millimeters per second. That's a rate of change. What's the slope? It's the same thing, except now we're not worried about labels. It's a rise of 5, run of 1. So the slope is a rise of 5, run of 1, or it's 5. Okay. So that's a look at some applications of rate of change and slope. Okay. That kind of wraps up what we're going to work on here. Take your time, make sure you work through here and got all the notes taken that you need. You're going to need to know some of that information regarding the formula for slope and the whole slope concept for horizontal and vertical lines. Make sure we're clear on that, and I will let you have at it.